the last case that we're going to be looking at is, what if we have vectors that are at odd angles? They're not perpendicular to each other. They're not just up, down, left, and right. Okay, so I'm going to set up an example of what if I have one vector that's down, okay, it's at a nice round angle, and then the other one that's up here at an angle. Okay, we're going to look at a down vector of 12 newtons and a vector of 10 newtons, and they're going to have to give you a direction here, so we just don't have to guess. So we're going to be at 20 degrees. That the other way around. 20 degrees. Okay, so we have two vectors. Okay, one of them is in a nice, cardinal direction, up, down, left, right. Okay, and the other one is at an odd angle. Okay, so the very first thing we have to do, anytime you have a vector that is not just up, down, left, or right, okay, that's not perpendicular to the other ones, the very first thing you have to do is break down that vector into its x and y coordinates, into its horizontal and vertical coordinates. Okay, so we're going to make a little triangle out of it right here. Okay, and we're going to find the x coordinates, and I'm going to keep x to be horizontal, okay, and the y coordinates, which y are going to be the vertical coordinates. Okay, and so we're going to go back to our trig functions of sine, cosine, and tangent. Okay, if I'm looking for the opposite side when I know the hypotenuse, I'm going to look at sine, because sine of my 20-degree angle should be opposite over hypotenuse, which is y over 10. Okay, now if I'm solving this in my calculator, I'm going to say it's 10 sine of 20 equals whatever y is, and y is what I'm looking for. So Mr. May is going to show you how it calculates out.
Calculator says 3.4.
Okay, is y should equal 3.4. Okay, so I have it up here. I'm going to write it in. This is 3.4. Now I need to find x, which is my horizontal coordinate. Okay, x is the adjacent side to that angle. So now if I'm doing adjacent and hypotenuse, I could use that side over here now that I know it, but remember, I'm always going to use the ones that were given to me because they're more accurate, I'm more confident about them. Okay, and so now we're going to look at cosine, because it's adjacent and hypotenuse. Cosine of that 20-degree angle equals x over 10. Okay, same thing, I move my 10 over and I have 10 cosine of 20, and Mr. May will show you the calculations.
The calculator says 9.4.
Okay, so for x, I get 9.4. So now that I have broken this down into y equaling 3.4 and x equaling 9.4, okay, I'm always going to stop. I'm going to erase the things I know because I have broken down this angle. I don't need it anymore. Okay, I'm going to get rid of all this. Okay, and I now know that I have a horizontal angle of 9.4 and a vertical angle of 3.4. Okay, newtons and newtons. So I have broken down that one angle I had into these two components. Okay, the biggest thing people will mess up is they'll get these components and they'll still try to use that other angle that they had. Once I've broken it down, I don't need it anymore. I'm going to use these things. So now we're going to go back to our cases. And the simplest of all of our cases was what happens if we have two things that are parallel. They're going in opposite directions. Okay, so I'm going to need to subtract them. So I got 12 minus 3.4. Now I plug that in the calculator. I get 12 minus 3.4. Okay, and I should get 8.6. Okay, so we look at this. I now have, I'm going to always redraw what I have. Every time I combine vectors, I have an 8.6 down, and I have 9.4 to the right. Okay, here are my two vectors. I've combined some more, so all I'm left with are two vectors. Now I'm back into my perpendicular case. What if these two arrows are perpendicular to each other? We have to work it out. We're going to set it up. Remember, you always set it up tip to tail, then you do the Pythagorean theorem. So remember, there are two different ways you can set up this triangle. It doesn't matter which one you do. Okay, I'm going to set up the 8.6 first. 8.6. The tip of this one hits the tail of that one. So that one is 9.4. So now I set this up, and I plug it into the Staggering Theorem, which is a squared plus b squared equals c squared, okay, which is 8.6 squared plus 9.4 squared equals c squared. Okay, now we're going to plug it into the calculator.
12.7.
Okay, we squared both of them, we square rooted it, and we get 12.7 newtons as c. Okay, this is our final vector. We've combined it all. We have our answer, and it is 12.4. Now,
12.7.
oh, sorry, 12.7. Okay, now the important thing is we found a vector. Okay, we just found the magnitude. Okay, and we're not done. A lot of people will stop at this point. Okay, remember, vectors have two characteristics. Vectors have a magnitude and direction. We've just found the magnitude, it's the value. Okay, so we know the value of it. Now we need to find the direction. Okay, so I need to figure out what this angle is. Okay, my answer is going to come down to this angle, and I know my opposite, I know my adjacent. So opposite and adjacent is cosine. Oh, sorry. Opposite and adjacent is tangent. Okay, so I'm going to do tangent of an angle I don't know equals opposite 9.4 over adjacent, which is 8.6. I'm going to plug it in the calculator. Remember, in the calculator, to move tangent to the other side, you're going to do the inverse. So Mr. May is going to show that to you.
The inverse tangent is 47.5 degrees.
So, if I have my answer here, okay, 47.5 degrees is my angle. What I would tell you is we have a value of 12.7 newtons at an angle of 47.5 degrees away from this vector.